Welcome to RichPlanet TV. I'm Richard D. Hall. Now on this show we have challenged the mainstream's version of history, and today we are going to talk about the history of physics and discuss claims that the holy grail of physics, the unified field theory, was discovered in the 18th century. Here to put forward his case is Roger Anderton. Welcome, Roger.
Thank you, Richard. Thanks for having me.
Okay, now just tell us a bit about yourself, Roger, and what first made you interested in physics?
Well, I think I've always been interested in physics. May go back to the time when Doctor Who scared me and I hid behind the settee. My career is, I basically had a try at doing A-levels and physics and maths, and sort of like found it too difficult and didn't carry on there. Then I went to, and I became a British telecom engineer.
Right.
And I got all the technical qualifications, like in telecommunications and computers and things like that. And you were doing things like physics and so forth. And so later on during my career, I went on to Open University and did physics and maths in Open University. And I was then looking for carrying on for, say, other things like postgraduate.
Right.
But I then found what I'd been taught wasn't correct.
Right. All right. So, and you call that the history that's taught in schools Whig history?
That's right. Yeah.
Just explain what Whig history means.
Whig was an old political party, and when they present history, they present it distorted as per their political bias. And so now it's a general term for a history which has got a biased point of view on it. And so it's really a false history. So if you want, and so when you go to university or get things like that, they teach you a false history of science, and they justify that by saying that makes it easier then to understand what they're trying to teach you from the theory and the experiments. You find out the true history is completely different to what they're teaching you when you're doing your science courses. And I'll have an example from this person here about
occultism and the atom, the curious story of isotopes.
Yeah, this historian has found that when you've gone back into the history of this subject, what they were doing, they were working from the occult philosophy in the early 20th century when they were doing isotopes, but because that was not respectable to believe in that sort of thing, they created a bogus history of what they were actually doing.
And you would contend that a lot of history taught in schools is Whig history?
It's just distorted of what really happened.
Right. Now, Newton and Einstein are two of the big figures in physics. Newton lived in the from 1643 to 1727. Einstein 1879 to 1955.
Yeah.
Now, you think that these two guys were probably less important than people have made them out to be, and that there are people who've been almost forgotten about, such as Tesla, for example. Yeah,
that's right. Tesla was very impressive. Before Einstein suddenly became famous, a lot of emphasis was on Tesla, what Tesla was doing, and sort of like Einstein, sort of when he became famous, sort of like overshadowed all the amazing things that Tesla was doing.
Right.
In his discoveries, you've got discoveries in Tesla which sort of like pretty astounding if you really believe them, but they try to divert onto Einstein.
And in one of your lectures you show a film, a modern day film where Tesla is portrayed. What's the name of that film, Roger?
Prestige.
Right, and just tell us.
It's a good film, but it's only fantasy. It has David Barry portraying Tesla, and there's several. Well, David Barry is quite amazing actor, and he's done a film, what's The Man Who Fell to Earth, and I kind of think the way he portrayed Tesla is sort of like an alien as well, because there's an amazing scene where he's walking through lightning, and that is kind of like an alien coming towards you.
Right.
And Tesla was doing all these amazing things with electricity, and he is pretty much the person who invented the AC power system, and he should be more recognised than what he really is.
Right. They're trying to portray him as some sort of fantasy.
Well, in the film, it's
science
fantasy.
fiction figure.
Yeah. But if you go into the conspiracy side of things, there are things like the Philadelphia experiment, and they say, oh, Tesla technology was used for that sort of thing. So you get sucked into all these sort of like diversions,
right?
Which is might be true, may or may not be true, but the theory that Tesla was working from is sort of like disappeared. Yeah.
I mean, I think if you look at the things that Tesla invented, stroke discovered,
yeah,
and their application in the real world, I would say they far outshine anything that Einstein came up with.
I would have thought so.
They're, for example, you mentioned the polyphase motor generator, an electricity grid system, and many other devices as well.
Yeah.
Einstein, well, would you need relativity if you were going to get into space, do you think?
Well, according to, if you believe in Einstein's relativity, it is very important to you for astronomy and so forth. And he did make these, did do these papers on the photoelectric effect, which is supposed to be used, helped in laser technology and so forth. So his theories are supposed to be very important for science as used, but it is kind of bogus in a way, because I don't reckon they're really properly using a lot of Einstein stuff.
Right, and you think that Einstein got certain things wrong as well?
Yeah. Physics, it's been heavily influenced by what Einstein has thought, and he's changed hundreds of things from what it was originally, and so it takes a very long amount of effort to actually study all that. But in conjunction with that 100 years or so worth of Einstein, there's been 100 years worth of criticism on pretty much everything that Einstein did.
Right.
And so it takes a lot of study just to look at the alternative point of view to Einstein. And I've got here what is called the
95 years of criticism of the special theory of relativity, 1908 to 2003.
Yeah.
Right.
And so they're documenting all the people criticising Einstein, and you've got a catalogue of the topics, if you can see it. There's all these topics of where they think the areas are,
right.
And people have looked at each of these things. Einstein's influenced each of these things in his way, and people have looked at what Einstein's done, influenced, and said, oh, there's an error. And so when they count the number of errors, people were claiming it goes into hundreds of hundreds of claims of error. So that's how big Einstein is. People have claimed lots of errors in Einstein's work.
Right. Let's come on to the unified field theory of physics. I'll just give you my sort of broad understanding of what that is. We've got forces in nature, one of which is gravitation. Another force is generated through magnetics or electromagnetic phenomenon, and then you've got forces inside atoms, which is usually termed the strong and weak nuclear forces. So you've got forces appearing in nature which shape the world, and it is believed that there's one underlying phenomenon which connects all of them together, and that is the unified field theory of physics. So, which, if you speak to a modern day physicist, they will say, well, that hasn't been discovered yet. Would you go along with that?
Well, that's roughly it. They've got several candidates which they claim will unify the forces, and the main one, I think, at the moment is they call it superstring theory. But there's other ones like quantum loop theory. So they've got these proposals for unifying the forces, and they've got the three forces like the strong, the weak, and the electromagnetic forces. They've got them unified in the grand unified theory, I think you call it. The problem they find is trying to unify gravity to that, because you're trying to unify Einstein's relativity with quantum physics.
Right. So when you say they've got them unified, there's one equation with all of the different terms in there that represent each force. Would you say?
Well, it'd be complicated equations, with matrices and things.
Right. Yeah. All right.
Keep adding extra bits.
Right. One character that we haven't mentioned yet, Roger, is Boscovich, who lived between 1711 and 1787. And you actually think that Einstein plagiarized some of his discoveries, or is that too strong a word?
It's probably too strong a word. I'm finding it.
Got his ideas from Boscovich.
I'm finding it very difficult to tie in Boscovich to Einstein. How much did Einstein know about Boscovich? I've got people who were working on the unified field theory with Einstein, because Einstein had a big fight with the establishment over quantum physics. He argued with them that quantum physics was wrong. And while they went off to carry on with quantum physics, he then went off to look for the unified field theory. And those people who were working on the unified field theory were sort of like ignored by the people who were working on the quantum physics. And so I've got the history of these people who are working on the unified field theory, and the people who are working on that, some of them were aware of Boscovich. So it is tied into Einstein's quest for the unified field theory. It's sort of like, it's to the mainstream physics. It's forgotten history.
Right.
It is known in the history of physics department
Boscovich
as an obscure subject. Some people in the history of physics do know about it, but they're a small number of them, and this information doesn't really get sent over to the working physicist people. There's no communication breakdown in departments.
Right.
The history department thinks if it was important, the physicists would ask me about it, and the physicists think I'm not interested in history.
Right. All right, Roger, we'll hold it there. We're going to have a short break, and after the break we're going to explain what it was that Boscovich discovered. Welcome back. I'm talking to Roger Anderton about the history of physics, and in particular Boscovich. We've got a picture of Boscovich on the screen there. Just tell us a little bit about him, Roger.
Yeah, in the 18th century, the Catholic Church was trying to recover from having persecuted Galileo, but they had the priests, the Catholic priests, some of them were still looking into the science issues of what Galileo was talking about, and so Boscovich is one of the top men they had looking into this issue. And I think this is supposed to be him, but he was looking at Newton's physics. And so he was what he considered to be the first Newtonian on the continent of Europe, and he advocated Newtonian physics, and a large part due to his influence, he managed to get the Catholic Church in the European countries to accept Newtonian physics.
Right.
After having banned that sort of physics with Galileo.
His life overlapped a few years with Newton.
I think so, yeah.
So, but he's certainly after Newton.
Yeah. The conflict at the time that when Newton died, which was left, was they had a conflict between Newton and Leibniz over physics. So you had people, and you also had Newton not having a complete theory. It didn't unify everything, and so Boscovich was into combining the ideas of Newton and the ideas of Leibniz and making a unified theory.
Right.
Hence why this is a unified theory. And what he was talking about was a sphere of influence around objects, which we can interpret as a field. So he was talking about a field influencing other objects. So it's a unified field he was talking about.
Right.
It's the first unified field theory I know about.
All right. Do you want to expand on that a little bit, Roger?
What my emphasis has been upon is translating his work, because most of his work has not been.
Yeah. This is a booklet that Roger has translated.
This is a chemist in Serbia who has worked on Boscovich's theory, and he's very impressive. He's got a lot of qualifications.
And you've translated.
He's written 60 papers or so on Boscovich.
What's his name?
Science Journal. It's Dragoslav Stokovich. So this is modern work on Boscovich's theory.
Right, and this guy's alive today.
Yeah.
Right.
And he sort of like I think he's advocating that it's a unified theory of physics as well, because he ties it into quantum physics. He's done the work.
And you've translated his document into English. He's saying that there is a field of influence around objects or matter, and that's characterized by this graph of his.
Yeah, the graph,
which is a force distance graph.
That is the force. That's how he's displaying the force between particles. There's an attractive force and there's a repulsive force between particles, and it's what we now say is a field. So there's a field for repulsive force and a field for an attractive force. And with Newton, he was only considering gravity as being attractive.
Right.
So with Boscovich, you've got more than just an attractive force,
yes.
You've got a repulsive side to it.
So if we look at that graph there on the screen, we see that the vertical axis is force and the horizontal axis is distance, yes?
Yeah.
So what that's saying is, as we move further away, out say from the centre of a particle, the force will pull you back, then it'll push you away. As you go further away, it'll pull you back again. As you go further away, it'll push you out again. So it's varying. So that would lead one to believe that there are certain areas that you'll be forced into, i.e., well, of the around an atom.
Yeah, that's right.
So is this defining the orbits of an atom then? This graph?
Yeah, Niels Bohr was working from Boscovich's theory when he constructed the hydrogen atom. He was considering electrons going around nucleus, and there was allowed and forbidden orbits. There was places where the forces was balanced, and there's places where the forces weren't balanced. And where they were balanced, there was an allowed orbit of the electron around the atom, or the atom's nucleus. And when it was not in that region of area space, it would be unbalanced force, and so it would either be pushed further in or would push further out. It's sort of forbidden areas around. That's the quantum levels of the atom.
And you can have so many on each level. If I remember from my chemistry, 2 and then 8, and then it gets a bit weird.
Yeah, that is a bit more on top of it from Pauli's exclusion principle and things, I think. But the basic idea of allowed and forbidden orbits around the nucleus is coming from Boscovich with his force theory.
So Bohr then, who came up with this different levels of electrons in the atom, do you think he got his theory from Boscovich?
Yeah, he did. He was working for Boscovich's theory.
Right. So why is it called the Bohr atom rather than the Boscovich atom then? Because is this all part of the Whig history thing?
You caught me. I don't know why they do that. If you're being more accurate, you probably call it the Bohr-Boscovich atom, but they've just called it the Bohr atom.
Right. All right. Well, here's a question then, Roger. So, if we come outside of the area of an atom and we get to say electromagnetic or gravitational forces, does Boscovich include gravity, for example?
Yes, gravity comes into it.
So can you show us that on? I mean, is that part of that same graph, or is that a different thing?
I'm not really got it shown on the diagram, but I'm in contact with loads of people, and one of the people is working out what is the characteristics of the graph. So I've got this person who's Augustus Prince, who's retired from Brookhaven National Laboratory, and he's looking into complicated issues like that.
Right. Okay.
So that should be hopefully published soon. It's supposed to have been coming out from a conference I attended. So
you would like to see Boscovich named as one of the pillars of physics in physics education, would you?
He was.
He was. Yeah.
I mean, the Catholic Church says that Boscovich is the father of atomic theory.
Right.
And he was the theory which the atomic physicists were using during the Manhattan Project.
Right. Right. Rather than Einstein.
Yes, I think so.
Because you were telling me earlier on that the people who were developing the atomic bomb didn't really get on with Einstein. I mean, wasn't Einstein a bit of a pacifist? Not that there's anything wrong with that, but
during World War I, Einstein was a pacifist. It's just, he wasn't. That's why the other Germans fell out with him. He wasn't patriotic, but during World War II, he sort of like gave up pacifism and decided you had to fight Hitler.
Right.
So he changed his mind on that.
Right. Okay.
But he wasn't involved in the Manhattan Project, which is the atom bomb project.
Right.
Other than writing a letter to the president saying look into building the atom bomb because he was afraid that Hitler was going to try to build one. Most of Boscovich's work hasn't been translated into English, so I'm trying to translate it. And you get, this is the Latin, so that bit there is using the word quantum, and quantum is a Latin word, so he is saying there quantum physics. But if you're looking at what the word quantum means in Latin, it comes out roughly meaning as much as. So it is a bit difficult to understand what is meant there. From a modern perspective, we would think of quantum physics, but as much as physics allows, he's saying. As much as physics allows, he's talking about Newton demonstrating something, a proposition, and it says as much as physics allows. So quantum physics is coming from the writing of Boscovich in the 18th century.
All right, Roger, well, we're going to go for another break, and when we come back, we're going to have a look at the very brief clip from a lecture from biologist Rupert Sheldrake. Welcome back. I'm talking to Roger Anderton about the history of physics. Now, Roger just is going to show us a clip from a lecture given by Rupert Sheldrake. Now, this lecture, you said to me, was banned, Roger.
Yeah.
And was that because Sheldrake does kind of stray into the area of physics in his work, doesn't he? Because he's really trying to get to the nub of what's really going on in biology, and that leads him to physics. So I gather a physicist complained at what he'd said in this lecture.
Well, a scientist, it might have been a physicist.
Right.
But
so it was taken off?
No, they banned it from the normal TED Talks. Right. TED is a collection of talks on by
Bill Gates.
Bill Gates. I have a lot of people on, and it's supposed to be promoting public understanding of science and so forth. Yeah. And there's too many protests about this. Sheldrake says lots of interesting things, and this is the bit I wanted to emphasise.
I want to spend a few moments on the constants of nature too, because these are again assumed to be constant. Things like the gravitational constant, the speed of light, are called the fundamental constants. Are they really constant? Well, when I got interested in this question, I tried to find out. They're given in physics handbooks. Handbooks of physics list the existing fundamental constants, tell you their value. But I wanted to see if they'd changed, so I got the old volumes of physical handbooks. I went to the Patent Office Library here in London, and they're the only place I could find that kept the old volumes. Normally people throw them away when the new values come out. They throw away the old ones. When I did this, I found that the speed of light dropped between 1928 and 1945 by about 20 kilometers per second. It's a huge drop because they're given with errors of only fractions of decimal points of error. And yet, all over the world, it dropped, and they were all getting values very similar to each other with tiny errors. And then in 1945, it went up, 48, it went up again. And then people started getting very similar values again. I was very intrigued by this, and I couldn't make sense of it. So I went to see the head of metrology at the National Physical Laboratory in Teddington. Metrology is the science in which people measure constants. And I asked him about this. I said, what do you make of this drop in the speed of light between 1928 and 1945? And he said, oh dear, he said, you've uncovered the most embarrassing episode in the history of our science. So I said, well, could the speed of light have actually dropped? And that would have amazing implications if so. He said, no, of course it couldn't have actually dropped. It's a constant. So, well then how do you explain the fact everyone was finding it going much slower during that period? Is it because they were fudging their results to get what they thought other people should be getting, and the whole thing was just produced in the minds of physicists? We don't like to use the word fudge. I said, well, what do you prefer? He said, well, we prefer to call it intellectual phase locking. So I said, well, if it was going on then, how can we be so sure it's not going on today? And that the present values are produced by intellectual phase locking. And he said, oh, we know that's not the case. I said, how do we know? He said, well, we've solved the problem. And I said, well, how? He said, well, we fixed the speed of light by definition in 1972. So I said, but it might still change. He said, yes, but we'd never know it because we've defined the meter in terms of the speed of light. So the units had changed with it. So he looked very pleased about that. They'd fixed that problem.
Yes. So is he right there, Roger, do you think he's right there that the speed of light was a tiny bit different during different times in the last century? Would you go along with that, or do you
yes. What he's said here is that the person he was talking to admitted that it was an embarrassing thing that they didn't find that the speed of light was constant.
Yeah.
And Einstein says in his theory, special relativity, under those conditions of inertial motion, the speed of light is constant. And so if he's making that claim, you would then test that by experiment. Mm-hmm. And you would then decide whether what he was saying is true or not. But as he's admitted, as he pointed out, they were not able to measure the speed of light constant. Mm-hmm. And so to overcome that difficulty, they defined the speed of light constant. And so that's two totally different theories.
Right.
And I've been to a talk recently in America, and it's a Reg Cahill, and he's pointed out, he's done a really thorough analysis of the Michelson-Morley experiment and other experiments, and he's saying from the data which they're ignoring, the speed of light is not constant.
Yeah.
But he's also admitting into the problem of the dogma of the science community. They're not ready, they're not wanting to accept that the speed of light is not constant.
My understanding is part of the problem is in that everything, matter itself, is dependent on light and the speed of light, i.e. matter is actually trapped light, in my opinion. Matter is, so there's a paper, I don't know if you've seen it before, that suggests that the electron is a photon with toroidal topology. And that's what an electron is. It's a photon going around infinitely in a loop, right? So light and matter are interchangeable. E equals mc squared.
Yeah.
So let me put this. How you perceive time depends on how fast your light is going around in your atoms. So if you move to a place where your atoms are going around twice as fast, for all time it appears to be going fast, you will experience it the same. So your clock is based on how fast your atoms go around, not on time itself.
What I mean here is that if you move to a place where light travels twice as fast, the atoms in your body will function twice as fast because the atoms are essentially trapped light. So you will function twice as fast. However, you will not notice this increased speed in your body's function because your perception of time is not based on an absolute value of time. It is based on the orbital period or motion of your atoms. So by moving to a place where light travels twice as fast, your time relative to somebody remaining at the other place will pass twice as fast. Your watch will run twice as fast relative to theirs, and you will age twice as fast relative to them. But your perception of your watch and your aging will remain the same to you. From this we can say that we as humans have no absolute perception of time at all. We only have perception of motion. This brings into question the very definition of time. If we have no real perception of time, can we really define what time is?
I would suggest that most instruments are based on atoms, therefore they're using it. So if the speed of light increases and you've got an instrument measuring it, it won't see an increase. Do you see what I mean?
Well, Charles Jake was pointing out that now that they're defining the speed of light as constant, if it does vary, you wouldn't notice it because you've altered your instruments. You're altering your instruments to keep it constant. And so it's not really a proper scientific theory if you're doing that. It's people sort of like talk about a scientific theory from philosophers like Popper is where you test a theory to see whether it's true or not. And with a theory where you're defining something, you've taken that part of the theory out from being tested. Mm-hmm. And so it's sort of like bogus to define it like that. And if everything Einstein has been so influential. Everything is coming from what Einstein has said. And one of his most fundamental things is about the speed of light. And if you suddenly say, well, the speed of light is not really constant, it throws everything else into chaos. So if Einstein is wrong, then you've got a mounting of paperwork, which is all nonsense.
My understanding is that light is a wave which is flowing through the medium of the vacuum of space. It's a pulse of energy flowing through space. So if that space changes in some way, its properties change, then the speed of that energy pulse, i.e. light, will change. I mean, to me, it's pretty... I accept that the speed of light is not constant, because doesn't space have a permittivity?
Yeah.
And if that changes, then the speed of light will change, surely.
Yeah.
So, now he talks about gravitation in this next clip, in the gravitational constant. But all of these constants, in my opinion, are dependent on space itself, and I think the role of space is underplayed in physics and in biology.
Yeah.
Because my opinion is, if you can understand the medium of space and the structure of space and define its behaviour, you will have a unified field theory.
Yeah.
It's about space, in my opinion. But we'll maybe come on to Nassim Haramein and people like that in a moment.
Everything is built upon Einstein, and if he got things wrong, then you go back to look for something earlier than Einstein. And so that's what I've done. I've gone back to look for earlier from Einstein, and I've come up with, there was a unified theory of physics before Einstein. And so if Einstein has sort of like added lots of things on top which are wrong, then it's all been 100 years worth of diversion onto the wrong tactic.
Right.
And so they're trying to cover this up now with their dogma about defining the speed of light as constant.
The military-industrial complex who develop secret technology, do you think they know that the speed of light is not?
Well, if we're going,
do you think that they're working on a whole different set of formulae in the black world, or do you don't go along with that?
If you're looking onto this conspiracy side of things about what are they doing in the secret,
for example,
science, then they could be completely different to what is in the public domain.
But I said, well, then what about big G, the gravitational constant known in the trade as big G, it's written with a capital G, Newton's universal gravitational constant. That's varied by more than 1.3% in recent years. And it seems to vary from place to place and from time to time. And he said, oh, well, those are just errors. And unfortunately, there are quite big errors with big G. So I said, well, what if it's really changing? I mean, perhaps it is really changing. And then I looked at how they do it. What happens is they measure it in different labs. They get different values on different days, and then they average them. And then other labs around the world do the same, and they come out usually with a rather different average. And then the International Committee on Metrology meets every 10 years or so and average the ones from labs around the world to come up with the value of big G. But what if G were actually fluctuating? What if it changed? There's already evidence, actually, that it changes throughout the day and throughout the year. What if the Earth, as it moves through the galactic environment, went through patches of dark matter or other environmental factors that could alter it? Maybe they all change together. What if these errors are going up together and down together? For more than 10 years, I've been trying to persuade metrologists to look at the raw data. In fact, I'm now trying to persuade them to put it online on the internet with the dates and the actual measurements and see if they're correlated, to see if they're all up at one time, all down at another. If so, they might be fluctuating together, and that would tell us something very, very interesting. But no one has done this. They haven't done it because G's are constant. There's no point looking for changes. You see, here's a very simple example of where a dogmatic assumption actually inhibits inquiry. I myself think that the constants may vary quite considerably, well, within narrow limits, but they may all be varying. And I think the day will come when scientific journals like Nature have a weekly report on the constants, like stock market reports in newspapers. You know, this week, big G was slightly up, the charge on the electron was down, the speed of light held steady, and so on. That's one area, just one area where I think thinking less dogmatically could open things up.
So that was it. He's pointing out the dogma. If science has physics has now become dogmatic in trying to stick with what Einstein was saying, and it's trying any trick it can to do it. And one of the tricks was to define the speed of light as constant.
Okay.
And it's not in the original.
Right.
Thought.
All right. Do you think that's just an accident? Why they are teaching, let's say, a blinkered view of physics, or do you think there's reasons why they're doing it that way? Do you think they're trying to hide information about the true nature of reality, in other words?
That is a big possibility. That the people who are working in places like they're called Area 51, they know physics is completely different to what they've been taught in the mainstream.
Right.
That is a big possibility. And so they're trying to then, the Americans are trying to keep that locked in, and they don't want anybody else to know about it.
Right.
And that's a military advantage to them to do that.
Right.
And so maybe that's what they're doing. They're trying to divert the academic world to go off onto these wild goose chases, while they've got their select few of scientists who know what's really going on.
Right. And Sheldrake talks about, or researches, telepathy,
Yeah.
and memory, and where memory is stored. He believes that there's a morphic field, and that your long-term memories are stored outside of the brain, resonating in space.
Yeah.
Morphic resonance, he calls it. And I know that Sheldrake has had, has been in contention with some people in mainstream science, and has had some successes against them in public debate.
Yeah.
But that's never put out on TV in the mainstream.
Yeah. I think when Sheldrake talks about morphic fields, then that sort of morphic resonance, and that really ties into a unified field where you've got gravity, electromagnetism. They all should be tied into a field, and so maybe what is happening from the mind is being opposed on that field as well, not just upon your body, but that is sort of outside of what they're trying to impose on us from Einstein at the moment. So it's a sort of like different physics, and it's.
So are you touching on the phenomenon of consciousness here?
Yeah.
Right. So would you care to speak about that a little bit, Roger?
I'm not really into that sort of area.
Right, right.
I mean, my sort of thing is sort of like, well, we've been working on Einstein for 100 years or more, and it's sort of like built on something which is wrong.
Right.
And so you need to go back earlier and then build on what was earlier than Einstein.
Right. One of the things which Nassim Haramein points out, and I find this quite amusing, is the Big Bang, and about how the expanding universe in physics textbooks, or in perhaps cosmology textbooks or astronomy textbooks, they show the expanding universe, more and more space being created over time, and they have all the mathematics for it, and they have a guy they actually have it as a balloon, like it's an analogy to a balloon. The surface area of the balloon increases as it gets blown up, and there's a guy actually blowing the balloon up, and the physicists are all working on the equations for the balloon, and he says, he's at his physics conference, and he says, what about this guy here? So why haven't you got any equations representing the guy who is causing the expansion of the universe? And his point being is, if you've got a massive expansion of a universe, you must have the lungs, which is a contraction. So in other words, everything is always in equilibrium. If there's a big bang, there's got to be a big collapse somewhere else causing the big bang. Do you see what I mean? I don't know where you stand on the Big Bang Theory and that kind of thing.
You've got cosmology at the moment built on Einstein's work, which is relativity and so forth, and they're trying to add quantum physics to that with people like Stephen Hawking. And then I've got people like Stephen Crothers, who's pointing out what they say in general relativity is really mathematically nonsense a lot of the time. So, but if you sort of like jettison that attempt at cosmology and go back to earlier Newtonian physics model based upon Boscovich's extended work, then his theory is about an attractive and repulsive force. And so if you've got a sort of like expansion, then it would probably, you'd be having a repulsion happen as well. Eventually you would sort of like have a balance, and maybe it collapse, and then maybe it gets a certain size and then it expand again. And so it's what I think a Professor Rosler talked about as a breathing black hole. So it's a non-standard black hole.
Right.
But
I mean, there's huge controversy over black holes now with the electric universe people.
It's what you have, you've got general relativity, and when they talk about black holes, they mean it from general relativity. But Stephen Crothers, if you need to talk to, he goes into a lot of explanation that the person who they get the mass from for black holes was Schwarzschild.
Right.
And they say this is a black hole solution, but when you go back to Schwarzschild, it's a completely different equation. So they're trying to foster on us that Schwarzschild gave us the black hole when his equation is completely different. So it's kind of like more falsehoods put in front of us again.
Now, you mentioned Stephen Hawking there, and funnily enough, I was drafting out my interview questions for Roger last night in the pub, right? And a guy comes up to me, a drunk guy, puts his arm around me and he goes, "What are you doing there, mate?" I said, "Oh, I'm just writing some notes." He says, "What's that for?" I says, "It's for an interview." He says, "Oh, a job interview." I says, "No, I'm interviewing a guy about physics and he went, "Oh, you mean the guy in the wheelchair?" Right. So people associate physics with Stephen Hawking. He's almost like a modern day Einstein. What's your opinion of Stephen Hawking, Roger? Do you have enough?
Well, he seems to be open to things, but he's still really working upon the mainstream point of view of physics, and it is massive books like that which he's sort of like building upon. He's building upon what he's been taught about relativity, and so he's building upon, which from my perspective has been a fundamental mistake at the very beginning of it. And so I want to go back to earlier, but there are other people who are working on unified field theory, like this person, I got Dr. Lau, who contacted me, and he's had massive loads of papers published in science journals, astrophysics and so forth, I think. And his explanation is that Einstein made 8 major errors in relativity.
Right, and he's trying to correct them.
Well, he's corrected. He's done the experiments, and he says he's corrected it.
Right.
And he's got a unified field theory. So his point of view then is that Einstein made those mistakes, but the people who came after him made even more mistakes. So it's a massive layers of mistakes, and if you go through the papers he's citing, he's arguing with these other relativists saying they've got it wrong.
Right, relativists. Okay. Now, the unified field theory. I'm going to just throw in a philosophical point here.
Yeah.
What all of these physicists are trying to do with this unified field theory, they're trying to describe what is reality.
Yeah.
Right? They're not looking at why it's there, are they? They're just trying to say, well, how can I write an equation which will predict what's going to happen in the future? In other words, how is this thing functioning? It's functionality. They're describing what it does, what reality does, but with equations. They're not describing why. Why it's there, are they? Do you see where I'm coming from? Once they've got, you see, I guess you have to answer that question, what is reality, in order to then ask the question, well, why is reality there?
Well,
Do you see what I mean?
Well, you could work, if you're really hard, I suppose you could work out what the equations are the universe are following, but then that describes what's happening. But then you could ask yourself, why is the universe following those equations and not following some other equations?
Yeah.
And that's all like getting really deep, and then you're getting into people saying, well, maybe the universe was designed, intelligent design, or then other people saying, no, it's random, it's the universe coming to existence, the only one possible. And it's all the other possibilities. I
mean, if you can get that unified field theory in one equation, some people would say, well, that it defines everything that there is. It defines God, it defines us, it defines everything in that one equation. But it still doesn't tell you whether it came out of someone's mind, or it's just existed forever, or why it's there.
Yeah.
Do you see what I mean?
Yeah, exactly.
In the Hitchhiker's Guide to the Galaxy, it says that there's a theory that whenever a person actually discovers the theory of everything, it's immediately replaced by a more complicated one.
Yeah.
All right. Okay.
Well, with unified field theory, you can just carry on working. You can with Boscovich, I think he does the basics of a unified field theory, and it's sort of then further work on that, and it does get more and more complicated the further you go on to it.
Right.
But you are still basically stuck with the maths describing the universe, and so why why is the universe like that? You never can know just from the maths, can you?
Right. Right.
Which is might be true, may or may not be true, but the theory that Tesla was working from is sort of like disappeared. Yeah.
I mean, I think if you look at the things that Tesla invented, stroke discovered,
Yeah.
and their application in the real world, I would say they far outshine anything that Einstein came up with.
I would have thought so.
They're, for example, you mentioned the polyphase motor generator, an electricity grid system, and many other devices as well.
Yeah.
Einstein, well, would you need relativity if you were going to get into space, do you think?
Well, according to, if you believe in Einstein's relativity, it is very important to you for astronomy and so forth. And he did make these, did these papers on the photoelectric effect, which is supposed to be used, helped in laser technology and so forth. So his theories are supposed to be very important for science as used, but it is kind of bogus in a way, because I don't reckon they're really properly using a lot of Einstein stuff.
Right, and you think that Einstein got certain things wrong as well?
Yeah. Physics, it's been heavily influenced by what Einstein has thought, and he's changed hundreds of things from what it was originally, and so it takes a very long amount of effort to actually study all that. Right. But in conjunction with that 100 years or so worth of Einstein, there's been 100 years worth of criticism on pretty much everything that Einstein did. Right. And so it takes a lot of study just to look at the alternative point of view to Einstein. And I've got here what is called the
95 years of criticism have been almost forgotten about, such as Tesla, for example.
Yeah, that's right. Tesla was very impressive. Before Einstein suddenly became famous, a lot of emphasis was on Tesla, what Tesla was doing, and sort of like Einstein, sort of when he became famous, sort of like overshadowed all the amazing things that Tesla was doing. Right. In his discoveries, you've got discoveries in Tesla which sort of like pretty astounding if you really believe them, but they try to divert onto Einstein.
And in one of your lectures you show a film, a modern day film where Tesla is portrayed. What's the name of that film, Roger?
Prestige.
Right, and just tell us.
There's a good film, but it's only fantasy. It has David Barry portraying Tesla, and there's several. Well, David Barry is quite amazing actor, and he's done a film, what's The Man Who Fell to Earth, and I kind of think the way he portrayed Tesla was sort of like an alien as well, because there's an amazing scene where he's walking through lightning, and that is kind of like an alien coming towards you. Right. And Tesla was doing all these amazing things with electricity, and he is pretty much the person who invented the AC power system, and he should be more recognised than what he really is. Right.
They're trying to portray him as some sort of fantasy.
Well, in the film, it's
a science fiction figure.
Yeah, but if you go into the conspiracy side of things, there are things like the Philadelphia experiment, and they say, oh, Tesla technology was used for that sort of thing. So you get sucked into all these sort of like diversions.
Well, the history that's taught in schools, Whig history.
That's right, yeah.
Just explain what Whig history means.
Whig was an old political party, and when they present history, they present it distorted as per their political bias. And so now it's a general term for a history which has got a biased point of view on it. And so it's really a false history. So if you want, and so when you go to university or get things like that, they teach you a false history of science, and they justify that by saying that makes it easier then to understand what they're trying to teach you from the theory and the experiments. You find out the true history is completely different to what they're teaching you when you're doing your science courses. And I'll have an example from this person here about
occultism and the atom, the curious story of isotopes.
Yeah, this historian has found that when you've gone back into the history of this subject, what they were doing, they were working from an occult philosophy in the early 20th century when they were doing isotopes. But because that was not respectable to believe in that sort of thing, they created a bogus history of what they were actually doing.
And you would contend that a lot of history taught in schools is Whig history?
It's just distorted of what really happened.
Right. Now, Newton and Einstein are two of the big figures in physics. Newton lived in the from 1643 to 1727. Einstein 1879 to 1955. Now, you think that these two guys were probably less important than people have made them out to be, and that there are people who Welcome to RichPlanet TV. I'm Richard D. Hall. Now on this show we have challenged the mainstream's version of history, and today we are going to talk about the history of physics and discuss claims that the holy grail of physics, the unified field theory, was discovered in the 18th century. Here to put forward his case is Roger Anderton. Welcome, Roger.
Thank you, Richard. Thanks for having me.
Okay, now just tell us a bit about yourself, Roger, and what first made you interested in physics?
Well, I think I've always been interested in physics. May go back to the time when Doctor Who scared me and I hid behind the settee. My career is, I basically had a try at doing A-levels and physics and maths, and sort of like found it too difficult and didn't carry on there. Then I went to, and I became a British telecom engineer. Right. And I got all the technical qualifications, like in telecommunications and computers and things like that. And you were doing things like physics and so forth. And so later on during my career, I went on to Open University and did physics and maths in Open University. And I was then looking for carrying on for, say, other things like postgraduate. Right. But I then found what I'd been taught wasn't correct.
Right, all right. So, and you call that of the special theory of relativity, 1908 to 2003?
Yeah.
Right.
And so they're documenting all the people criticising Einstein, and you've got a catalogue of the topics, if you can see it. There's all these topics of where they think the areas are. Right. And people have looked at each of these things. Einstein's influenced each of these things in his way, and people have looked at what Einstein's done, influenced, and said, oh, there's an error. And so when they count the number of errors, people were claiming it goes into hundreds of hundreds of claims of error. So that's how big Einstein is. People have claimed lots of errors in Einstein's work.
Right. Let's come on to the unified field theory of physics. I'll just give you my sort of broad understanding of what that is. we've got forces in nature, one of which is gravitation. Another force is generated through magnetics or electromagnetic phenomenon, and then you've got forces inside atoms, which is usually termed the strong and weak nuclear forces. So you've got forces appearing in nature which shape the world, and it is believed that there's one underlying phenomenon which connects all of them together, and that is the unified field theory of physics. So, which, if you speak to a modern day physicist, they will say, well, that hasn't been discovered yet. Would you go along with that?
Well, that's roughly it. They've got several candidates which they claim will unify the forces, and the main one I think at the moment is they call it superstring theory.